Hello, Internet. An idea came to mind for a topic for a video. So every now and again, a friend who's not a programmer will ask me, they'll see a bug in some software they use, and they're like, Ben, how did this happen? You're a programmer, isn't it all numbers? How could something go wrong? It's just algorithms, right? So I thought I would talk about some of the ways that things can go wrong from a couple real-life examples, and also a thing that's like, it's a famous example among programmers, kind of. I wonder how many even programmers know. Let's just get into it. So imagine that you are making a 3D game, because this apparently is important for 3D games. And your wonderful graphics people say, hey, Ben, oftentimes you're going to have some value, and we need you to take 1 divided by the square root of that value. It turns out to be useful to have like light bouncing off of surfaces and other things like this, right? And you're like, great, I'm a smart programmer, I can do that. There is a function built in called squirt, which stands for square root. And so this is what you would type. And actually, sorry, this should be a y. So here's the value given to me. It's this x. I'm going to take the square root. I'm going to do 1 divided by that, and that becomes my new thing. And this is approximately how you would write it. 30 years ago, this was too slow because there are a lot of pixels on your screen, even if it's an old CRT, like 640 by 480 or whatever the heck they're running at for this game. So this is, by the way, Quake. I don't know if you've heard of Quake. Old game by now. They've made newer ones. Is there a modern Quake? There's modern Doom. I really have no clue. But anyway, this was too slow because you needed to do it for every single pixel on the screen, maybe. Which again, 640 times 480, how many pixels is that? Again, I'm making assumptions that maybe it ran at a lower resolution than that. I don't know. But still, thousands of times. And also remember, your game wants to run many times a second. I don't remember what kind of the standard accepted frame rate back then would be, if people were happy with 30. Nowadays, if you're less than 60, someone's going to be annoyed. But maybe 30 was good enough. Still, way too much for the computer. So someone crazy smart came along. I mean, okay, first of all, there's 2 things. Okay, we've got a bug. Our game is too slow. That's just because this is too fast. You want more lighting. So here's already where you can make a trade-off. You could go back and tell your like level people or business people or whatever, it's like, we just can't do it. Computers are too slow. That's a fair constraint, right? There's nothing we can do about that. Computers are as fast as they are. You're just going to have to do less lighting effects or whatever. Or you could be someone who's super clever and heard about an insane algorithm on the internet and say, oh, you're giving me an x that you would like 1 over the square root of, and you need it given to a y? Do all this bullshit. So what is all this bullshit? I can't fully explain it to you. I'll put a link to the Wikipedia in the in the description. It's called the fast inverse square root. I know like technically what some of this stuff is doing, like this star-long star stuff. Without getting too, I don't know, floats. You're basically, again, everything is ones and zeros in a computer, right? People like to say that, and it's true. And you're coercing the computer to say, hey, I know you're thinking about this number as being one type of number, but let's pretend it's a different thing and then do some weirdness to it and then put it back to what it was. I don't know how to get into it without getting super technical. But this is what it is, right? This is bananas. This is insane. It's not perfect. It is not a perfect 1 over square root. There's a margin of error. So like, you could look at this code and be like, it's buggy. It does not compute 1 over the square root of x, but it does it faster and it does it accurate enough for a low resolution screen on a slow computer. That was 30 years ago. It is still important today. There are still small devices that do things like run inside people's bodies if you've got a pacemaker or something, and the human body moves I don't know how many times per second, but depending on how important it is that you get real time, as close to real time information as you can get, you might need to make little trade-offs like this, and you're making a choice on, we want longer battery life, maybe for a little less accuracy, but the accuracy doesn't matter now. But the accuracy could come to matter, right? So maybe later on, so first of all, computers got faster pretty quick, and you didn't need this anymore because people built things into the hardware to be fast enough. But you can imagine a period of time where maybe the screen resolutions got bigger, but this was still the fastest thing to do. And with more pixels, maybe the inaccuracies start to show, right? Do you go back and say, hey guys, we're just going to have to drop the frame rate a little bit for the, right? Whatever. Things can change, right, is the point. The hardware can change around you, and things that weren't issues before might become issues. I wanted to, so I have a concrete example of that from my previous job, but first I want to talk about an even simpler problem, because this might be like, what the hell, that's hard to think about. Here's another problem. This is one I ran into as a kid. When I was making games as a kid, also like 30 years ago, mine weren't 3D, but they were 2D, and I knew that I had a problem. There was something I couldn't do. I knew that if I wanted my guy to move, to the left 1 pixel, or whatever, I could do that, move over 1. And if I wanted to move up 1, I could do up 1. If I wanted to move diagonally, and sorry, the backwardness of the camera is freaking me out again, I didn't know how to do, oh God, I really don't know how to move my finger for this. But anyway, I didn't know how to do this. I knew that I wanted you to move a distance of 1, but I didn't know how much that meant to go in the X and Y. And computers are displays. You've got pixels that run down and pixels that run across. If you want to go to a pixel some distance in a direction, you have to know how many over and how many down, or how many over and how many up. I didn't know about trig yet because I was in elementary school or middle school, so for a long time I just never knew how to do this. Eventually I learned about square roots, square root of 2, and that I was like, okay, now I can do 8 ways, but what about in between? What about like just a little bit, up from straight across? Once I learned trig, I remember having like the mind blow experience in math class of like, oh, this solves a problem I've been having as a kid for years, not knowing how to do something so silly and simple. Now we've got engines that'll do all this shit for us. But I had a similar problem as this problem. I needed to do sines and cosines maybe 60 times a second, and it turned out that that was too slow. Partly because of computers at the time, but also partly because of the programming language I was using at the time, which was BASIC, which is an interpreted language. It is just slower. And so I devised a solution that is used in a lot of places and could be used for something like this. And that was just to pre-compute all the values I needed. So, I knew I wanted to let people move 360 degrees. So I said, okay, when my program starts up, I'm going to count from 0 to 360, do the slow, hey computer, calculate the cosine, calculate the sine, and then store those results in a little list somewhere. And then whenever I need it in the future, when I want to actually move someone like this, rather than asking the computer to do the computation, I would just look up the value from the list that I had. This is another trade-off. You are so where does that number go? I pre-computed those values. Where do they go? They go somewhere. They go in your memory, in RAM. This is a very common trade-off in programming, generally just caching. And I don't know, do you consider it a bug that a program needs more memory to run than another program because it decides to save a bunch of stuff because it needs to be fast enough? Do you consider it a bug if it requires so much memory that you can't run it on your computer anymore, right? What if someone releases an update to software and like, why can't I run this software anymore? And they're like, oh, sorry, the memory requirements increased because we got to pre-compute some shit. Or whatever, right? I mean, it usually doesn't come down to any one thing, but these things are happening all over the place. There's tons of stuff being cached. Another thing that can happen, computing a sine and cosine, the answer will never change. Until the end of time, the cosine of 24 degrees is the cosine of 24 degrees. But a lot of times what happens in computers is you've got some data that's just somewhere far away. And far away, I put it in quotes because far away might be it's in the same room physically, but it's on another computer. A database is a great example. So you're using some sort of website. If it's saving data, it's, you can come back later and it remembers all the things you put. That's because it's put in a database somewhere, and that lives on a different system. Every single time that you use, that website, it doesn't want to have to keep looking up and say, who is this user again? They logged in, their email address was Ben at Google, whatever, .com. That's not a real email address, clearly. I don't want to have to keep looking up that person's details anytime, so I'm going to save them locally in a little table, similar to the sine and cosine thing. But what if it changes? What if something else about that record changes? Maybe it's because I did it. Maybe I go in and say, oh, change my name now. It's not Ben, it's cool internet guy, and now I want the website, to reflect my name. Okay, probably the programmer was smart enough to think, hey, when they go to this form and update it, then it should update the name. What if there's like admin tools that people can use to update the values? Or what if they don't have admin tools? What if you can call up and say, hey, there's an issue with my account, and they go into the database directly and tweak the value? Does their application know that that has happened to grab the thing? They might not have coded for that. Someone has to have coded for that. There's some quote in programming that's like the two hardest things in programming are naming things and caching. And then there's like a funny alternative that says that the two hardest things in programming are naming things, caching, and off by one errors, which is a common thing. I could talk about why computers start counting from 0, but that can cause confusion. So anyway, off by one errors can happen. So anyway, that's just another thing. So all that kind of like caching stuff, right? It sounds like a great solution, but there's trade-offs there. More fast square root math, okay, it's faster, but it's not as accurate. Is that okay for your use case? Maybe it is. Another thing, so one more example, and then this video is over. At my previous job, we had a bug come in. And the bug was, we've got this user who, for whatever reason, isn't getting emails. And someone figured out eventually why they weren't getting emails. And the reason they weren't getting emails is because this person's last name literally had an apostrophe in it. It was an O something, you know, I don't remember, let's say O'Connor. I don't know, it was O apostrophe whatever. And when they signed up for work and when their administrator gave them a work account, they said, great, I'll put an apostrophe in your email address. we will respect your last name. I have a hyphen in my last name, and I've run into some related problems, but hyphens, for whatever reason, confuse people less than apostrophes. People think of hyphens, they don't think of apostrophes. So this is very old software that I was working on at this job, like 20 years old. And at the time, for whatever reason, you know, people said, hey, I'm gonna, you know, when email addresses come in through our system, I want to make sure that someone didn't put in garbage nonsense for the email address. So if there isn't, you know, it's got to be letters and numbers and an @ sign. Maybe periods are allowed. Again, probably they allowed dashes because a lot of people do, but not apostrophes. The person programming at the time just didn't think about apostrophes. Fair enough. And, you know, maybe you're like, oh, that's so stupid. That's the programmer's fault. They should have thought of apostrophes. But let me ask you a question, because this is the question I asked. Do we need to support emojis? Everyone's going to say no, Ben. We do not need to support emojis. No one has emojis in their email address. No one thought they had apostrophes in their email address either, right? Like, what's your cutoff? When do you say, yes, do you allow, I mean, there's other symbols. What about a degree symbol? Or you know, you can, on a phone, you can hold down the E and get an E with an apostrophe. Guaranteed we didn't support that in our email address validation. Is it allowed to have E with an accent mark on it? Right? And another, email addresses are kind of funny in particular because there are standards on what is allowed for an email address. The standards are way more complicated than what you can think of. If you listed 10 of the weirdest email addresses you thought were valid, they're not as weird as the email addresses that actually are valid. Very bizarre email addresses are allowed. By the standards, most email providers like Google and Microsoft and Yahoo, they don't care. They have more strict requirements than the standards technically allow, and they're all a little bit different. So one trick you may be aware of is that you're allowed to put, with some providers, you're allowed to put a plus in an email address. So maybe I have my ben@google.com. I could have ben plus blah at google.com. And according to the standards, plus extra means it doesn't matter, send it to the same email address. And that's really good if you want to have multiple email addresses. You know, if you want to sign up for some sort of website and they say, give us your email address, it's got to be unique. You can say, okay, well, here's ben plus 1, ben plus 2, ben plus 3, etc. You can do that. There was a time when a lot of email providers didn't support that. Google was one of the few, and then later other people started to support pluses in email addresses as well. So, I mean, the point being, in theory, there's a standard. In practice, not everyone agrees. What if, and you interact with these systems, right? And they might start changing. Maybe your email address validation worked for a long time and you never allowed pluses, and then all of a sudden, pluses now start being supported by all these people that never supported them before. Now they're coming into your site and people saying, what's this bug? You're not supporting pluses. And you're like, well, sorry, no one did pluses before. It wasn't supported by everyone, even though it's part of the standards. The standards for email addresses were also written before emojis were a thing, before Unicode, which is what emojis are built on. So do they say anything about that? Probably not. I mean, they can't. It didn't exist. So I don't know. Maybe there's some, I haven't read in a long time what the precise email standards are. So, it's up to human interpretation. When you look at this, you're like, well, I don't know. Are emojis allowed in email addresses? Who knows? So yeah, things can change all around you. And again, even if you say, well, okay, look, I'm going to be super cool and support emojis, maybe other people that you interact with don't. You say, well, we don't personally send emails. We go to a third party like Amazon because they do cloud hosting. One of your cloud providers that you might be living inside of, your application lives inside of, maybe they don't support the things. And you're like, well, I wish I could support the standards, but the other people that I talk to don't support the full standards. So I have to have this bug in my system because I'm effectively working with others who just don't do whatever. So anyway, there's a million reasons. I mean, another thing that I didn't talk a whole lot about is just things change over time. And when you have like a 20-year-old piece of software and someone comes in and says, hey, Ben, we would like you to make a change in this system. We need to now support apostrophes, for example. I didn't work on that particular ticket, or did I? I don't remember, but the point is, guaranteed, even if I worked on it, I did not find every single place in this 20-year-old code base written in a language that I'm not even that familiar with, but they put me on the job and said, hey, Ben, we hired you for C#, but sorry, you're going to do Visual Basic. And I'm like, I don't really know Visual Basic, but okay. This is code written by people who probably don't even work there anymore, right? A lot of the time, have weird names for things. I mean, a great example is this code. Why is it called like I and Y and X2? What is the importance of this number? When you're going through code and you just don't know and you're just making your best guess, you're like, what does this do? And by the way, people have since found there's better numbers to use than this one to get more accurate inverse square roots. This isn't the most accurate number possible. How do you determine the accuracy of that number, right? I mean, these things are bananas. Programming is very interesting. It is not as clear-cut as it seems. I mean, another thing that comes up too that we talk about, there is an aesthetic part of coding. Like programming languages are expressive enough that there's many ways to solve the same problem. Besides just this, many things actually give the same result. But even they have trade-offs of like, how readable is this code? How many assumptions are kind of built in? Like, it's really easy to just forget. I mean, I ran into this today. So we've got, sure, here's another example from today, a real-life example that I was debating with my boss. And it's like, this isn't good. I'm not willing to commit this code that I see a bug in. This has to be fixed if we're changing it. And I was eventually convinced, never mind, we're not going to fix it in that way because we need to answer other questions first. So here's what it was. We want to send emails to people when they are charged for... there's an invoice. There's something that says, you owe us $100. Okay, we're going to charge you $100. But we're changing the system now so that rather than just charging one big invoice, it has line items. And so now you want to actually think about the line items individually. We didn't used to store those. Now we're storing them in this different way. And so now there's old code floating around that, you say, hey, here's a payment. Get my invoice, but it's not like that anymore. Now a payment says, here's my line item, and that's attached to an invoice. So technically, one payment could end up going to like multiple line items, and each of those line items points to a different invoice. And there's nothing that technically requires that all those invoices are on the line items, all those line items are for the same invoice. Like they should be. It would be very bizarre to not be, but it is possible. When you look at this function in the code, you're like, I'm asking each of these line items for an invoice. It could be different. There's no guarantee to me in this particular piece of code that they are the same. Do you just accept that they probably are and probably always will be? That's it. Or do you add checks? And if you add checks, what should happen? Should it fail? When it fails, should it email some? What should happen? I mean, those kinds of things can happen all the time. So anyway, programming is very weird. It is not just numbers and algorithms where there's one definitive answer and that's it. It is squishy and bizarre and very complicated. Yeah, and this example is, I just look at this and go, who came up with this? It was a number of people. If you look, it was like some guy heard about an algorithm. I think it was, who was it? It wasn't Newton. There was some old mathematician who had figured out some approximate way to do it and turned a programmer onto the idea, and he went, ooh, I think I can implement that, and that would be faster. So it was like this weird multi-step process, but what an interesting story. And very short-lived usefulness, because then computers got better anyway. But again, still, these kinds of trade-offs get made all the time. So anyway, that's it. Quite enough rambling. 20 minutes. Oh my God, just talk about nonsense programming. Thanks for watching. Bye.